actually. But
At least it's not cancer. At least it's not a cancer.
that's, yeah.
Old age is the best.
Actually, what kind of sucks? I don't want to die old.
Why?
Because you're like,
For old kids.
frail and like,
Thank you.
in that generation. I'm not even gonna lie to you. I'm not gonna speak this generation.
You don't want to see Robbie at 10 miles under
We did not pick those names.
I like Miles.
I like Miles.
Jessica, I think that one. It's just like,
Jessica.
I do know what that is.
Oh, what about Robbie?
I don't hate that. Robbie.
I hate that.
Okay, here we go, everybody. The hope is we're just going to do a few practice problems, kind of go through that pattern process, and then you should have plenty of time to get your homework done mostly in class. That's the goal today, okay? So these are the basic steps whenever you're solving any type of stoichiometry problem. Now, once again, all that word stoichiometry means is saying, hey, if I want to make this much water, how much of this should I start with? Or, if I have this much to start with, how much can I make? Or, if I have this much of A, how much of B, so that they react completely. It's just comparing reactant to product, product to product, reactant to reactant, in various units, okay? So let's write these down just to kind of have them as a reference. I'm going to kind of, once again, make my color codes here, okay? So first off, you need to understand what you know and what you don't know. Or like how I like to say, you need to know where you're starting on the map and where you're ending on the map, right? If you're going to go somewhere, you got to figure out, well, where am I starting and where am I going, okay? In terms of our map, okay, that I gave you here, okay, the arrows are the road. You can't ever start on a road. You have to start at a location. So you got to figure out, okay, where am I starting? Where am I going? Okay, the other way that this map is always set up is you're always going to go from the left side to the right side because you know it, and then you're trying to find what you don't know, okay? All right, in terms of the problem, what I always like to do when I read a problem, and I still do this today when I'm problem solving, is I circle what am I trying to find in the problem, and I underline what I know. That way it just becomes very clear my start and end goal, okay? All right, we're always going to need a balanced equation because, once again, that's what bridges the map together. Without a balanced equation, the map is not connected, okay? We'll then set up our conversion map, and this is where we'll have our various parentheses following the patterns, okay? So those are kind of, once again, just the basic pattern we're going to follow every single time. All right, and then if you turn your page over, you have a copy of the map yourselves, so that you can use it at home and things. You'll notice the one in your notes is filled in a little bit more than the one I've given you, but the one I've given you also has more boxes. So we'll talk about that here really quick. Okay. So on this one, there are certain places that we, I guess, will not start at or travel to yet. Later on in the year, we're going to learn more of them. So if you want to take the marker I passed out to you right now, and we're going to cross them off just so as today it doesn't confuse you. Okay, so cross off the boxes that aren't found in the map in your notes. And if you're unsure, it can help clarify. But or maybe do this to help everyone else. So what's one of the boxes on your one on your desk that's not up here? Yeah, so get rid of the kg of solvent. You're never going to go there. And then the other one is the liter of the solution. So it's the ones on the top and the bottom. So you won't ever use those in this unit. So, okay. Now, what is in between the boxes is the thing that connects those two things together. For example, if we were to make a roadmap with English units, okay? So let's say, just as an example, so if I was making a different type of roadmap for English units, and I was connecting feet and inches, what connects feet and inches together? 12, right? Because there are 12 inches for every 1 foot. It's the this, Avogadro's number, is what links particles to moles. And then up top, the thing that connects grams to moles is the molar mass, which is how we calculate on the periodic table. Okay, so keep that in mind, that that's what the arrow is representing, is what connects these two things together so we can relate them. Okay, let's try a problem. Okay, our problem here says, how many moles of potassium chlorate are required to produce 8.5 times 10 to the 22nd molecules of oxygen? All right, first step. What are we trying to find in this problem? Perfect. Everyone take your pencil and circle that. We're trying to find moles of potassium chlorate. Okay, so step one is like always, what am I trying to find? Step two, where am I starting? So what do I know that I have? Cam?
You know that you have 8.50
Good, so everybody underline that whole thing. So that's what I know. The red is what I'm trying to find. Okay? Do that first, because then it will start kind of piecing itself together. All right, my next step is then go to your map and figure out from the beginning, how many steps is this going to take me? So, what am I starting in? Molecules. Okay? On here, which box is, so remember, always pick something on the left, because we're going left to right. So, what is representative of molecules on here? Good. Everyone put a star with your marker in that particle box. We're going to draw on our map. Okay, so put a star in it, say I'm starting here. Okay? Where are we trying to end on our map? Moles, say it again. Moles unknown. So put a star in this one over here. Craig, how do you know it's not moles known? Yeah, it's kind of like, that would be if this was asking for moles of oxygen. So notice I'm in oxygen and I'm changing to something new. If it was just oxygen to oxygen, then it would just be that one step that we did back in the last unit, okay? Okay, so then, if you connect on your map here, so I keep using it as an example, okay? So if I connect this, this is gonna take me 1, 2 steps. Because I have to go here to here, and then I can go here to here. Make sense so far? Okay. Oh, I forgot to give you guys a map. Oh shoot, I'm all out. Let's see if I can still one. Who can
Wait, what are you looking for?
They don't have a map over there.
Uh-oh.
Katie, could you look at Emma and Shay? Is that okay? Well, but then I want you to draw on it with us. Okay, so now take what we underlined, and that's our starting point, okay? So I have 8.50 times 10 to the 22nd. Now we've got to keep our labels because that will help keep it track, okay? So I have joules of O2. Joules is like my abbreviation for molecule. I made that, by the way, it's not real. But molecules is a lot of work. Okay, so starting point, write that down. Okay, now we're going to set up. Oh, my one's dying. Let's see. Our first conversion. Okay, the pattern always goes, whatever unit is here must go there. So I'm going to go joules of O2. The way I think of it is the bottom is the place you're leaving. The top is the place you're going. So on our map, what's the first stop that we're going? Moles of known. So on top of my fraction here, I'm converting this into moles of O2. stop me if you have a question. Okay, I'm gonna keep going with my map because it's 2 steps. So we've traveled from this box to this box. Now we've got to travel from this one to this one. There's no airplanes in this town. Sorry, you have to drive everywhere. Okay, so following the pattern, I want to leave moles of O2, so that will go on the bottom. And what am I trying to find? Good, so moles of our potassium chloride, which was this guy again. Once again, notice the pattern of the colors before we even put any numbers in there. Right? Diagonal, diagonal. The only thing that doesn't have a diagonal should be the thing you circled, because you don't want to travel anywhere else. Okay? Okay, questions so far with the setup? Okay, now the numbers. Now, the numbers that go here are independent of the problem. It doesn't matter what I'm starting with. This is what makes these 2 things connected and always true. Just like with inches and feet, it would always be 12 to 1. It's what connects moles and molecules together. So what connects those 2 things together? Good, so Avogadro's number, now that's the 6.02 times 10 to the 23rd. Don't say it out loud. Point with your finger. Does that number need to go on the top of this fraction or the bottom of this fraction? Tell me what you think. Show me, if you don't know, you can point sideways. 6.02 times 10 to the 23rd go on the top or the bottom? Well, at least those that are answering, I think, some are, besides the unsure ones, I think all those that were pointing down, which is correct. Can someone in their own words tell us why? Yeah, like.
Well, it's there's 6.02 10 to the 23rd molecules in 1 mole, so that we don't have that many moles. We have that many molecules.
Perfect, and he's bringing it to life and making it make sense, right? There's this many molecules is 1 mole. It's just like it goes inches and feet. You got to make sure the 12 goes next to the inches. It's not a matter, you can't memorize like, oh, always on top, always on bottom, because they can flip, but what is always true is it has to be equivalent. Okay, very good. Have some ideas, Blake. Okay, now this is comparing moles and moles. So what bridges that gap, Cam?
Would be like when you use like the formula.
Perfect, so mole to mole is always the balanced equation. So 3 moles of O2 for every 2 moles of KClO2. And then at that point, your calculator does the work. Questions so far? Now, few reminders with calculator typing in. Have we talked about the E shortcut for those that haven't?
Yeah.
Okay, I would highly recommend that. Use the particles still. So the way I would type this in my calculator, this is my personal preference, I think it's the fastest, okay, is I would do 8.5, I would do the E to the 23, okay? This is on the bottom, so you have to divide it. Now, this is where some of you messed up on the test because I could see what answer you put and I could tell what mistake you made, like last term. Avogadro's number, if you don't use the E shortcut, has to be put in parentheses. If you use the E shortcut, it groups it like by default. Does that make sense? But if you don't put this in parentheses by order of operations, it gets messed up. Okay, so then I would go 6.02 E to the 23, and then 2's on the top, so I would do times 2. 3's on the bottom, so I would divide 3, and then I hit equals. That's how I choose to type it in. I don't like typing in fractions if I don't do that. Anything that's a number 1, I can ignore because mathematically it doesn't. So, and I can help if you're not getting the right answers typing these in. Please let me help you because that's the worst to have the right setup, but you're getting the wrong answers. Does somebody have an answer for us? I can type it in myself.
Yeah, 0.94.
0.94.
Yeah.
Do you have a second?
I got 0.0.
Is it 0.094?
Oh, missing a 0. more than one person who agrees with this?
Wait, so for, it says 6.02 times 10 to the 23rd, would you change it if you're not using the E shortcut?
Oh, I wrote 23 here. That might have been why, Cam. If you typed in what I wrote, I wrote the wrong thing. Sorry, say that one more time, Sam.
Okay, never mind, I guess that's probably,
Oh, did you figure it out?
maybe, yeah, because I got 24.
Yeah, I think it's, so if you typed in what I had written up here, that's why your 0 was off. Because I wrote the whole thing down, so. Okay. Label this. What does this represent? Moles of KClO3. Okay, questions for now? Okay, stand up. Take a breath. My goal is to help you guys stand. Class. I struggle. I know.
Okay. Alright, what do you want me to do about that? No way. But no, there's no big one. Could you not just sit in the car?
Okay, so we're gonna do one more together. A little bit faster. And then I'll have you kind of try one with your paper. Okay? But once again, stop me. Oh, take your paper towel. And erase your map. It is like the fastest week and the longest week ever.
Wait, we used to not.
You'll get the map on yours. It will look like this one, so it doesn't have much on it, but yeah. So if you didn't hear, Cam asked about using the map on this quiz, and yes, you will have access to use the map
Wait,
when you take it.
when is the quiz?
Not till it's a pretty long minute, so yeah.
I thought you meant today, and I
Oh,
was like,
are you
I
ready,
was like,
Katie?
what?
Oh, that's lovely. You have a very sticky marker. But add this to it now. I'll push it up a little bit. Okay, here we go. Grab your pencil. Let's circle what we're trying to find and what we know. How many grams of silver will be formed from 1.20 moles of copper? Okay, so before I do it, then just make it worse. Oh, well, just go with it. Okay, before I do it, see if you can circle what we're trying to find, underline what we know, and draw it on your map of how many steps this is going to take. Okay.
Or you're writing it the equation on paper too.
If you want to. If you want to follow along with me, I am going to do it on the board, but if you feel like you want to try it, you're welcome to. Okay? Alright, but first off, if you circle this and underline that, so if you circle this, have a smiley face. If you underline this, have a smiley face. And if you identify it's going to take you 2 steps, have a third. Say what? It's the work, not the work. And it's better.
Yeah. I don't have it. I only see videos of people getting ready. Like the models getting ready.
Get rid of that.
Did you get 3 too?
Just like,
I want my glitter from
I saw that. Our circle.
Okay, so follow along with me silent, you can do it on your own. Okay, so I'm starting in moles of copper. Using my map, I see the first place is I need to go from moles of copper to moles of silver. Right, because if you look at your map, to get to the end destination, the first step is you gotta convert from one substance to the other. So I'm gonna go from moles of Cu to moles of Ag. Fun fact, by the way, this is the exact equation we'll do in our lab reaction. So this is the reaction you guys are gonna do to make silver. Okay, all right, so then I want to leave moles of silver, so that will go on the bottom. And I want to get to grams of silver, so that will go on top. And at that point, my setup is done. Once again, I always do my setup first, and then I worry about the numbers. Because the numbers, once again, feel easy once you have the big picture laid out. Okay? All right, mole to mole connection is always the balanced equation. So copper, there's one of those. Silver, two. Okay? Mole to gram connection. Molar mass periodic table. So silver has a molar mass of 107.87. I keep 2 decimals. So 1. And then at that point, calculator does the work. It would be just this times 2 times 107. There's only one going on. Questions on setup or numbers or where things came from? If it's feeling magical, meaning like, oh, that just came out from nowhere, it shouldn't. It should be quite logical of where everything came from. So if something feels magical, let me take away the magic.
Did you get the copper on the left side and the silver on the right side?
For this right here, Easton?
Yeah.
Yep, so because I'm just looking at Cu by itself, so that's why I looked at just
Okay.
this.
Okay.
Because technically, like this isn't copper
Yeah.
with a bunch of it.
Okay.
So did that clarify what you're asking? Yeah, good question.
How did you know it was moles of silver for the first equation?
On the first step,
Yeah.
so that's kind of where the map can help you a little bit in that I was starting here and I'm wanting to get to here. And so the first place I have to go is mole to mole.
Okay.
The other big thing, which hopefully you'll kind of get, is moles is the only thing that allows you to change substances. So if I'm in copper and I want to get to silver, the mole is the only thing that does that.
Okay.
So does that help, Abby? Yeah, good question. Any other questions for now? Does someone have an answer for us? So we can put an answer up here.
Josie does.
258 grams of silver. Oh, we can be making lots of silver.
I was supposed to
Isn't it
round.
8-9?
Yeah. Should it be 8-9 if you're rounding?
It's technically 0.888.
Oh, okay, so for 2 decimals.
Should I answer?
Did that answer your question, Jamie, for rounding?
Yep.
So always just round it 2 decimals. And it's not like, you don't need to stress too big about the rounding. Because like on the quiz, it's designed to give you some flexibility if you didn't round to 2. Rounding isn't a big deal, so don't stress about rounding. But okay, any other questions for now?
Where's that?
It's
not coming off.
I think it's a lamination.
Hand it to me, Isabella. Let me I have a magic
Red
brush.
marker over.
Yeah, it's kind of like stuck on here.
Okay, go ahead. Here's what we're gonna do. You're gonna try number 3 with your table button. Say what? The sprayer, yeah. Okay, once you have your work and answer, raise your hand. If you are correct, then I will give you today's homework to get started. If you're not, then we'll get you to be correct. And then go, Lizzie, do it.
My parents.
No! Nate got into another little.
Oh, I accidentally put that. I commented.
You what? Oh.